Two identical blocks X and Y, each of mass 2 kilograms, are connected by a string. They move on the same surface. A force F accelerates the blocks at 0.5 meters per second squared. The frictional force on block X is 4 newtons. What is the tension in the string? So let's consider forces acting on the blocks and then the second Newton's law. So for X it's tension, the frictional force of 4 newtons, and vertical forces are not required here. Why? Because the second Newton's law says that the vector sum of all forces is equal to ma, and it's a vector equation, and it should be considered in projection onto some axis or in components, and it will be enough to consider a horizontal axis only, so that vertical forces will have zero horizontal components, or the projections onto x-axis will be zeros. So let x-axis be horizontal and be positive to the left. So forces for y, it's tension of the same magnitude, so T and T. Why? Because it's an action-reaction pair, and since two blocks are identical and they are on the same surface, so the frictional force on y is also 4. And let's consider the second Newton's law for y. So projection of T on x-axis, it's parallel and in the same direction, so it's T. 4 is parallel but in opposite direction, so minus 4. Its component or its projection onto x-axis is negative 4. And it is equal to ma, mass of y, it's 2 times and 0.5, because they have the same acceleration. And we can see that we can find T. It's 4 plus 1, it's 5 newtons. So it's C, and that's all for this question.